Welcome back. Section 2-4A is our topic today. We're going to split 2-4 into 2 days. One has to do with just looking at equations with variables on each side, distributive property. The second day we'll talk more about fractions. So let's start off just a quick reminder. Steps for solving equations. If you need to, I didn't mention this before because we didn't need to in section 2-3 when we just had multi-step equations. We're going to use the distributive property if needed. Notice this problem. I've got 3 with a parenthesis x minus 4, 2 with a parenthesis x plus 1. So we would distribute, get rid of parentheses. Look at each side of the equation and combine like terms. You can't combine across the equal sign, but you certainly can combine when they are on the same side of the equal sign. So I'm even going to put a little shade up so you only look at one side. And then you're going to get all variables. If in doubt, get them on the left side. All numbers on the right side. It'll be a multi-step equation once you get your like terms combined. Right? So you can have variables on the opposite sides of the equation. So let's start off with problem number 2. Now 1. We'll skip 2. So I've got a negative 2 plus 10x equals 8x minus 1. Now obviously there's no distributive property to look at here because there's no parentheses. So we're skipping that first step. Next thing we're going to do is we're going to look at each side. If I just look at this half, are there like terms? Can I combine the negative 2 and the 10x? Nope. If I just look at this side, can I combine the 8x and the negative 1? Nope. So there's nothing to do with that either. So now we're just going to go to step 3, which says, when in doubt, get all your variables on the left, numbers on the right. Some people, if you're good in equation solver, you might not need to do it that way. But if in doubt, it always works that way. If you like a little line down the middle to remind yourself that what you do on one side of the equation, you do on the other, that often helps people. So I'm going to take this 8x. To get this to the other side of the equation, I have to subtract it. No sign means it's a positive. So when I do that, these 8x's cross out. These 8x's combine now, right? Because they're both x's. So that gives me a 2x positive. I'm going to bring that negative 2 right down. And all I've got left on the right is a negative 1. Some people do it in a different order. It doesn't matter as long as in the end you get your variables to one side, your numbers to the other. So now I want to get this negative 2 to the other side of the equation. How do I get rid of a negative 2? Inverse operations means that I add 2 or I combine it with a positive 2. So those guys cross out. I'm just left with a 2x equals negative 1 plus 2 should give me a 1. And now we all know what to do, right? Last step, to get that x by itself, let's divide by 2. Is it okay to get a fraction 1/2 or a 0.5 as a decimal as an answer? Sure, why not, right? We could go back to the original equation. We could put a 1/2 or a 0.5 in for the x's on either side and see if we get a true statement when we do the math. All right. Let's jump over here to problem number 4 because there's lots of like terms to combine. We'll skip 3 for now. So problem number 4, first of all, I definitely see distributive property, 2 of them, right? 1 on each side. So go ahead and distribute. So I've got an 8x plus 8. That plus 4 is not doing anything but coming straight down. Here when I distribute, I get a 6x and a negative 24, and that minus 16 is coming straight down. If you want a little line on your equal sign, go ahead and do that. But now I'm going to ask you, if I just cover up 1/2, I'm going to look at each side. Are there any like terms over there on that left-hand side of the equation I can combine? Well, sure. I've got an 8 and a 4, which is 12. The 8x just comes right down. Over on this side, do I have like terms that I can combine? Well, yeah, definitely. I've got a negative 24 and a minus 16. Don't put too many minus signs in there. I think if my math is right, that comes out to a negative 40. Bring the 6x straight down. And now I can put my equal sign because I didn't have room before. Some people are going to do that and not combine them and just add 24 to both sides, add 16. You can do that. It's just more steps. So I try to make it as streamlined as possible. So next thing I'm going to do is I'm going to get all my x's to the left. So this x right here needs to go. How do I get rid of a 6x? Subtract it. Notice I'm going to write it underneath the 8x because I can only combine it with other x's. So when I do that math, I end up with I shouldn't have crossed that out, a 2x plus 12. These guys definitely cross out, and I'm just left with a negative 40. So now I want to get this plus 12 to the other side. How do I get that out of there? Subtract it. When I do that, those guys cross out. I'm left with a 2x equals negative 52. And then everybody knows what to do last. Divide by 2, and you should get a negative 26. Please notice all the work I'm showing. You must show your work. There were a lot of steps there. I've got 1, 2, 3, 4 steps, and then my final answer. So please show your work. Hopefully this is reviewish. We do need to talk about no solution. Everybody knows that no solution symbol is the 0 with the cross through it. When you're solving an equation, here's how you know that it's no solution. Whoop. You know because you've got here's what it means. No value of the variable will ever make the equation true. No value of the variable will ever make the equation true. Here's what it looks like in the equation. There are no variables, and you have a false statement. So this example that I have over here on the right, let's do this so you know exactly what it looks like. So I've got a 5y minus 6 equals a 5 in a parenthesis, 6 plus y. Everybody sees a distributive property, right? So let's distribute this. This left-hand side of the equation, nothing changes. This right-hand side, it looks to me like it's going to be a 30 plus 5y. I'm going to ask you that same question. Are there any like terms I can combine? Nope. How about on this side? Are there any like terms I can combine? Nope. Which means I'm ready to just get my variables to the left, numbers to the right. So if I want to get this 5y out of here, I'm going to have to subtract 5y. I didn't put my little line here. When I subtract 5y, what do you notice happens? What's 5y minus 5y over here? No y's, right? So all I'm left with is a negative 6. On the right-hand side of the equation, I've got 30 plus, what's 5y minus 5y? Nothing. All of my variables went away. The 5y's all subtracted right out of there. So I'm left with negative 6 equals 30. Does anybody like that? Negative 6 is not equal to 30, not even close. So I'm going to go down here and I'm going to say there is no solution because I've got no variables left and it's a false statement. So there is no number we could ever choose. We could try every possible number from now till infinity and we would never get an answer. So all real numbers, or the identity, or the symbol that you could use is an R with a double R. It just means all real numbers. That means that the equation is true no matter what value you use for your variable. The equation is true no matter what value you use for the variable. And it looks like no variables left when we do an example. No variables left, but this time we have a true statement. Last time we had negative 6 equals 30. So let's do a little math. Let's do this example so you have something to look at so you see what it looks like. I'm going to put my little squiggle down my equal sign. And of course we're going to distribute. I don't even have to ask. 2w plus 6. Do you see like terms? Did you zone in on any like terms that we can combine right away? Any like terms for a 2w plus 6? Nothing, right? Not like terms. We can't say that's 8w or something ridiculous. Any like terms over here? 7 plus 2w minus 1. We've got a 7 and a minus 1, so how's that look for a 6 plus 2w? All right, so now let's start getting those variables on the left, numbers on the right. So I'm going to start by getting rid of this 2w by subtracting 2w. So what happens when I subtract 2w? These guys cross out, right? So I've got 6 equals. These guys also cross out. I've got 6 equals 6. Everybody agrees that's true, which means on my answer line, I'm going to say all reals. Any number I choose, 0, -8, 16, 3, 4, anything I put in for w, I will get a true statement no matter what. So that is no solution in all reals. I think we're probably good as far as practice because we practiced those two, one of each of those others, and come with questions tomorrow to class. And please explain how you know if your equation has one solution, no solution, or all reals for your solution. I didn't specifically say one solution when we were practicing the first couple, but we did get one solution, right? We got an answer. And here's a nice little problem for you. It's got a fraction in there. Don't be discouraged or scared because we're just going to use distributive property on both sides and everything should work out nice and neat. That is it for section 2-4A. Have a fabulous day. See you next time.